Alright there guys, Reese here from Stoic Pool, and in this video we're going to be having a look at our first unit test for our market buy redeemer case. Let's get into it. First things first, we can write any tests for any helper functions or anything like that that we really want to do, but we're not really going to focus on that right now because it's quite obvious how to do that once you have a look at this stuff, which is much more important in my opinion, which is testing our validators. And the way that we can do this, we can run tests on validators. We used to have to put it all in one file, and you'd end up having 100 lines of code for your validator and then like 600 lines of code for tests. But in Aiken, you don't have to do it that way. You can actually import your validators into test modules to run tests that way. And so now we can separate them essentially, which makes it a lot easier to work with. So first things first, we're gonna, in our market folder for module 1, or module A, we're gonna call it from now on, we're gonna create a new file and we're gonna call it tests.ak, and this is gonna be our market tests. Now we're going to import our validator, and we do that by saying use and then just follow the path like we normally would. So we'll go use a/market, and I've written /market again here, but you don't actually need to do that. I'll remove it in a second. And then we write our test by using this test keyword, and then we're going to put market by, which is a function, and in that body we're going to write market.market.spend, and this is because we're saying the market module dot the market validator dot spend purpose, okay, which is like the function in our market validator. And our spend purpose takes a market datum, a market action, an output reference, and a transaction. And then we can start building out these elements. So we're going to start with our transaction, and we're going to say tx equals a transaction, and then we're going to open up those brackets. Transactions have a huge amount of fields. If you remember back to when we were looking at the standard library, there are loads and loads of fields, and it would be an absolute pain to write all those out manually every time, even if they're just like null values or empty lists or whatever. It would just be, you know, RSI basically. So the Aiken team have this lovely little helper function called placeholder. So we can say ... placeholder, and what placeholder does is it basically generates an empty transaction. So there's no inputs, no outputs, no signatories, no redeemers, no voting, no withdrawals, no nothing. And this is great then, because then we can just insert the values that we actually care about for our test. So we can put inputs, which is a list of inputs, and outputs, which is a list of outputs. Then if you remember our market validator, we need the buyer to be paying the seller and the buyer to receive the assets. So we need an input from the buyer, an output to the seller, an input from the marketplace, which is the OREF that we're spending, right? The transaction we're spending in our test. And we need an output to the buyer with that asset, or with that value, sorry. So I'm going to write buyer in, market in, buyer out, and seller out. So now we have our transaction written. The next things we need to do is build out our other fields for our spend test. So we need to write our output reference. So we'll say that OREF is an output reference, and an output reference takes a transaction ID and an index. And so we can fill those in. We're just going to put our transaction ID as cafe and the index as 1. Next, we should probably define our seller and our buyer so that we can differentiate between their inputs and outputs with their payment credentials, right? Because addresses have payment credentials and state credentials. And so we're going to make a seller called face and a buyer called beef. Now you'll notice I'm doing like a hash and quotes, and what this is basically defining a hex string or a byte array, because they're byte arrays. So I'm going to call it byte arrays. I know I've said strings before, but it's actually a byte array in Plutus. That's what it recognizes. So it's not really a string. A string's for tracing, which we'll get to in a different video. So we've got our market buy, we got our seller and our buyer, and now we can build out our datum and redeemer. So we're going to say let market datum equal a market datum type with a price of 200, and the seller is seller. And then we can say a market action of buy, but it's not buy in a market action, it's actually mbuy, so we'll just change that to mbuy now. So before we build our inputs and outputs, there's one more thing we need to do, and that's create like a dummy NFT or like a dummy asset value for us to put in our market transaction, the thing that we're trying to buy, or that the buyer is trying to buy and the seller is trying to sell. So we're going to do that by saying let market value equal assets.merge. And assets.merge, if we just go to the standard library, we can go down to merge, and we'll see merge takes, oh, that isn't zoomed in like I'd hoped. There we go. So merge takes two values and it merges them together. I know it's not rocket science, but it's nice just to have a look at the function because you never know what it's returning or what it expects coming in. So when we do our market value, we say assets.merge, and then we're going to say assets.fromLovelace2, and that's just to cover like a dummy min UTXO value. In real life, it would be more like 700,000 Lovelace, but it doesn't matter. We're just putting something in to remind you as the person taking this course that values need a min UTXO value. So we can never expect it to just be the asset because it never will be. Like, it physically cannot be. It always needs a min UTXO value. Of ADA, by the way, of ADA. I know I just said min UTXO value, but it needs to be ADA. There needs to be some ADA in that. But anyway, it doesn't matter. So we're going to merge our Lovelace value of 2 and an asset from asset. And from asset in our standard library. From asset literally just constructs a value from an asset identifier. So we need a policy ID, we need an asset name, and we need an integer, which is the quantity of those tokens. So we're going to say assets.fromAsset, and then we're going to say dead for our policy ID and feed for our asset name, because they're both going to be hex strings, right? And a quantity of 1. So now we got all these variables in place. The next thing we want to do is write our inputs and outputs for the transaction. So we're going to start with our market input. So we'll say let market input equals input, and an input has an output reference and an output. So we're going to say input with an output reference of OREF, because the market input is the transaction that we're actually trying to consume, the UTXO that we're trying to consume, the one that the buyer is trying to buy and the seller is trying to sell. And then we can put our output as output, and an output has an address, a value, a datum, and an optional reference script. And we're just going to put that as none because we're not going to be using it, so we'll leave it as none. For our datum, we'll put our market datum. For our value, we can put our market value. And for the address, we need to actually build the address. So we'll say an address which has a payment credential and a state credential. And we're going to give it a payment credential of def. And this is technically the script hash. All right, but we don't actually need to put the script hash in, so we don't need to like use the script hash from our Plutus.json, but we could, but we're not going to. We're just going to write def, and then we're going to have a state credential of none. So that's our market input. Now we can do our buyer input, and we can do our buyer out and seller out. So for our buyer input, we're going to just copy and paste that input in so we don't have to write it all out again. And we're going to make sure our buyer is beef, our payment credential. So we're going to change that to buyer. And then we're going to change our value to an assets.fromLovelace of 200 and a datum of no datum. Wallet UTXOs don't generally have datums because we don't generally send datums to and from each other. It's only when they're used specifically for like a specific purpose that they'll have a datum, and so we don't generally have a datum. You don't really need to think about that too much. Just it doesn't need a datum. It's probably not going to have a datum. We definitely don't need it to have a datum for this test, so we'll leave it as no datum. So now we got both of our inputs. We can write our buyer output, and our buyer output is going to be let buyer out equal output with an address, a value, a datum, and a reference script. And it's going to have no reference script, no datum, and we're going to give it the market value, and for the address, we'll give it a payment credential of buyer with no state credential. So the last one to do now is seller out, and we're going to say let seller out equal, and we're going to just copy the output from buyer in, we'll paste it further down, we'll change the payment credential to seller. And the reason we took it from buyer in is because we want to be sending that buyer input value, the 200 Lovelace, to our seller. All right, so we just done that to save the hassle there. And all we need to do is change that payment credential to seller. So we've got our buyer in, our market in, our buyer out, and seller out. We've got our market data, market action, OREF, and our transaction. So we should have everything we need in place now to run this test, so let's give it a go. First off, before I forget, because I will, we need to have all our inputs. So we're just going to say use Cardano transaction. We're going to add our transaction input, output reference, and we're going to add no datum and inline datum. And we're going to say use Cardano/address and import the address type. And we're also going to import our assets, so Cardano/assets. And before I forget, we need to import our placeholder function as well. Cool, so we fixed that. We also need to import our course types for our market datum and mBuy redeemer case. And we can run our test, and it says it's errored, and that's because I just wrote tx instead of let tx, so I haven't defined it as a variable, I've just written a thing. So we'll say let transaction, and actually while we're here and we're fixing these things, there's a couple of other bits that we need to do as well. So our datum in our function isn't just a market datum, it's an optional datum. So we need to change this market datum to some market datum. And then we also need to change the datum in our input to an inline datum. Cool, and this time we get another error, and this error is saying it's inferring a payment credential. So it's expecting that we should have a payment credential, but we actually just have a byte array for our payment credentials in our addresses. And that's because we've included a dummy hash, but we haven't specified whether it's a verification key for a wallet credential or a script for a script credential. So we need to do those things. We haven't added them in, we need to do them. So first off, we're going to import verification key, and then we'll scroll down and we'll change our buyer input, our buyer output to a verification key, and our seller out to a verification key, and our buyer in to a verification key. And we can run it again, and you see we've still got an error, and that's because of our script input, so our market in. So then we can change that to a script, and we can import script. All right, so now we fix those errors. When we run Aiken check, you'll see an output like this. It says a/tests, which is our test module for our validator, has passed, and the one that's passed is market buy, and then we get this mem and CPU, and these are the execution units for our validator, so, or for this test at least. So, and this isn't like a perfect benchmark, but it is a good indicator of how expensive it is to run this validator. Now, this will change based on how much information you put into your test and how much, and whether you're importing things from different modules, blah, 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 but it's still a very good idea. And it gives you some feedback when you do things like optimizations later down the line. We'll be able to compare these different tests to see how successful our optimization strategy has been. All right, guys, that's it for this video. We've written a parsing test for our validator to prove that the market buy redeemer case functions as we expect. There are 2 other redeemer cases, so there's at least 2 other tests we need to write, but I think it'd be good to write a failing test as well, so we can show you how you do that and what a failing test looks like. But we're going to be writing a lot of tests in this course, and you generally, when you're writing validators, you're going to be writing a lot of tests. So the first thing we're going to do is we're going to turn these tests, so that we're not writing input, transaction ID, like the different output references and everything else over and over and over again. We're going to turn this into like a little test module, and we're going to build some helper functions out of these things that we've written so that we can reuse them over and over again, and it'll be a little less RSI intense. All right, so that's it for this video. I'll catch you in the next one. See you then.